Hey bro, can we use calculus in this?
Let's think.
We begin this video with a question. What does sharks and machine guns have in common? Well, the answer might surprise you. In 1910s, there was a marine biologist named Umberto married to Luisa Volterra, the daughter of our today's hero Vito Volterra, who was renowned mathematician of that time. Umberto wanted to impress his father-in-law, and to impress the mathematician inside Vito, he did what every other person would do. Bring him an interesting question. Well, in 1910s, there was something other also happening. Yeah, that was World War One. Umberto was researching on the population of fish in Adriatic Sea. He took reference from the fishing records of that time. Umberto noticed that the population of carnivore fish was more than that of herbivore fish. Well, we can now answer the question of how machine gun and the sharks were related. Well, they both flourished in World War One. Umberto was stuck with the question of how war was good for carnivorous fish like sharks and bad for herbivorous fish. You see, during the war, people were too much occupied with, war, and due to which fishing and other activities reduced significantly. But Umberto was not able to come up with a solid solution to the question. Well, he went to the hero of our video, Vito Volterra. This way, a time period plagued by war and death gave rise to theoretical ecology. At the same time, Alfred J. Volta developed same sort of equations, thus giving the name Lotka-Volterra equation. Well, to come up with the equations, they made some assumptions. Here we will classify fishes into two types. The carnivorous fish, we will call them sharks, and the prey fish, and we will call the herbivore fish as prey fish. The first assumption was exponential growth. It meant that prey fish's population grows exponentially and each individual gives offspring. Well, this assumption was wild, but we can give it a break, as this assumption was the first attempt of how we see the nature around us. Second assumption was that sharks' eating rate was proportional to the population of prey fish. For example, if population of prey fish triples, the eating rate of shark would also be tripled. Third assumption was that sharks need to eat to reproduce. The number of offsprings shark produces is proportional to the amount of prey sharks eat. The gestational period, the maturation period of sharks is neglected. Last assumption is that the lifespan of shark is predefined. So if there is no prey around, the shark would die out. Using these assumptions, the equations sometimes look like this, and the graphs were also plotted.
The graphs are something like this. The left side shows the variation of shark population with respect to time, while the right side shows population of prey with respect to time. We will see how abundance of each of them changes as time unfolds. First, the population of prey species increases. This is followed by increase in sharks. As sharks start eating more, the abundance of prey decreases. This is followed by crash in shark population. As shark population decreases, the prey population increases, followed by the shark population. And this cycle continues.
Well, we can now add fishing into the equation. Fishing acts as a permanent pseudo-shark which competes with shark in terms of prey. Thus, fishing more prey leads to decrease in shark population. Meanwhile, there can be an instance where fishers catch shark instead of the prey fish. Thus, fishing increases the chance that shark dies out before eating enough to reproduce. This would increase the prey population. We can say that more fishing leads to less shark population and less fishing leads to more shark population. And so, we can see that Vito-Volterra's model matches the observation made by Umberto. This is also applicable in the apple orchards. To kill the pest, you would think to gas them out. But if the natural predator of the pests is also susceptible to the pesticides, then it can lead to increase in the pest population. This was especially seen during the 1950s in China, where mass killings of sparrow and other pests took place under the order of government. Sparrow, being the natural predator of insects which were harming the crops, were killed in large numbers. This led to surge in insect population, leading to destruction of even more crops. This was one of the reasons behind the Great Famine of China in those times.